What if I told you that deep beneath our feet, an invisible army is at work, mining for some of the world's most valuable metals? And what if I told you this army is made of bacteria? Welcome to G Fun Facts Online, where today we're uncovering the secrets of the unseen miners and a revolutionary technology called biomining. Forget giant trucks and explosives for a moment. Biomining harnesses the natural power of microorganisms, bacteria, fungi, and other tiny life forms, to extract precious metals from ore and even from old mining waste. It's a quieter, cleaner, and incredibly clever way to get the materials that power our modern world. So, who are these microscopic miners? The stars of the show are a group of microbes called chemolithotrophs, or, more simply, rock eaters. Unlike us, they don't get energy from organic food. Instead, they feast on inorganic minerals, like the sulfur and iron compounds found in metal ores. By metabolizing these minerals, bacteria like acidithiobacillus ferrooxidans effectively break down the rock around metals, setting them free. Think of it as the microbes digesting the ore. The two main techniques they use are called bioleaching and biooxidation. In bioleaching, the microbes directly dissolve the metal we want, like copper, making it soluble in a liquid solution. We can then just collect this liquid and extract the metal. Biooxidation is used when the metal, like gold, is trapped inside other minerals. Here, the microbes don't dissolve the gold itself, but they break down the mineral cage that surrounds it, making the gold much easier for us to extract with other methods. To put this microbial workforce into action on a large scale, engineers use several methods. In heap leaching, crushed ore is piled onto a large pad and a solution full of these special microbes is sprinkled over the top. As the liquid trickles through the pile, the microbes go to work, and a metal-rich liquid is collected at the bottom. An even more futuristic method is in situ leaching. This avoids massive excavation entirely. Instead, the microbe solution is injected directly into the ore deep underground through boreholes. Then, the liquid containing the dissolved metals is simply pumped back up to the surface. So what are the spoils of this microbial labor? A surprising amount. Around 10 to 15% of the world's copper is now extracted using bioleaching. About 5% of all gold is produced with the help of biooxidation. The technology is also used for uranium, nickel, and zinc. But perhaps the most exciting frontier is for rare earth elements. These are the metals critical for everything from our smartphones to wind turbines. Biomining offers a promising way to extract them with a much lighter environmental footprint. And that really is the biggest selling point: the green advantage. Biomining requires less energy, produces fewer greenhouse gases, and reduces the need for harsh chemicals like cyanide, which are often used in traditional mining. It allows us to process low-grade ores and even old mine tailings that were once considered waste, turning a liability into a resource. Of course, it's not a perfect magic bullet just yet. The process can be much slower than conventional mining, sometimes taking months or even years. But the future looks incredibly bright. Researchers are hunting for new microbes and even using genetic engineering to create superminers custom designed for specific jobs. The potential applications are expanding in incredible ways. Scientists are exploring urban mining, using microbes to recover valuable metals from our mountains of electronic waste. And the idea goes beyond Earth. Experiments on the International Space Station have proven that microbes can successfully leach minerals from rocks, even in the harsh conditions of space. This means biomining could be an essential technology for future explorers building habitats on the Moon or Mars. From cleaning up our planet to helping us reach for the stars, this tiny, unseen workforce is poised to make a monumental impact. The microscopic miners are just getting started.